I'm going to first introduce a perspective about climate change and the urgency for action. That won't take very long because you, no doubt nearly all of you would have seen hundreds of slides and talks about climate change, but there's a need to introduce it. I'll then talk a little bit about the management, history, fire and hydrology issues in the Jarrah forest, which is where I'm going to concentrate most of the talk. And in particular introduce fire in natural lands, so my main emphasis is going to be the southwestern forests. Talk about the implications of climate change for fire management, and finish up with sort of how the new climates are going to influence the way we manage fire in connected landscapes, such as our southwest forested areas. Not many slides are just all words, just the first couple and the last couple. But why should we focus on climate, fire and climate change? These 4 points, I think, make it clear that certainly bushfires are one of the most deadly types of climate-related extreme events in Australia, as in other Mediterranean climate zones around the world. And there is a link between climate change and bushfires, but it's a multifaceted and complex link. It's much more difficult to tease apart than, say, heat waves or cyclones. Thirdly, fire is a naturally occurring tool. It can be used and managed. It's available to managers for broad-scale natural intervention in landscapes. So it's natural that we should have an interest in it because we can do things with fire. Fire also offers scope for different management approaches to ameliorate the damaging impacts of climate change on the biota and on human society. So I hope that's enough reason to give the talk. A little about climate change. I think just sufficient to show this slide actually. In 1859 was a very important year. That was the year The Origin of Species was published, Charles Darwin's monumental work, which changed the whole way biologists look at the world. It was also the year that John Tyndall published a little paper which experimentally verified the greenhouse effect. Experimentally verified. He actually used the ideas from previous, Fourier's ideas, to demonstrate how the greenhouse effect works. So we've had 150 odd years of understanding of the greenhouse effect. Human impact on global CO2 is obvious, and you all probably know this, and I'll rip through this slide quickly. But emissions of carbon dioxide equivalents are on an upward trend, and they've been so for some time, and I won't spend any more time on that. Further, there's overwhelming evidence and no doubt that the climate's changing. Here's just three bits of information you can pop out of any of the IPCC reports or other areas. For example, the sea level changes, the global surface air temperatures and the melting of ice are all moving faster than we would expect. And it's beyond doubt, beyond reasonable doubt, that human activities, particularly the burning of fossil fuels and deforestation, are triggering the global climate changes. And this graph, I think, emphasises that, in that the blue lines there are the natural forcings, or modelling of the natural forcings from solar activity and volcanoes, where you would expect climate to be going. But if we add in the human as well as the natural forcings, then we get the red shading. And if you trace where the climate's actually going, you get the black line, which follows the red shading. So, and it's the same for all continents and oceans and the world over. How much warming's likely? Well, quite a lot. This was a bit of a scary paper from 2008 from Anderson and Bose, where they were sort of economist types, and they just look at budgets. And a budget approach does tend to rule out delay in terms of taking action about climate change. Because a tonne of CO2 emitted some decades ago is the equivalent of a tonne of CO2 emitted now, in that it stays in the atmosphere for some considerable time. The issue is that if you peak your emissions and then try to get them down, and you need to get them to something like 350 parts per million, it's going to be quite difficult. And the further it climbs, the harder it is to get down. And it's hard to imagine it getting down suddenly. Of course, there are ways that might happen. For example, if we switch to various renewable or clean energy sources, these things could happen quickly. But my bet is it's not going to happen as quick as we'd like. These people, Anderson and Bose, argue that 4 degrees is almost certain. Quite a serious prospect, written in 2008. And there were conferences. There was an Oxford conference in 2009 on 4 degrees and what that means. So this is old stuff now, and I'll finish on climate change now. Just start to talk a little bit about what that means. This normal distribution graph there illustrates for just any one variable what happens when you change. For example, if you have a, say, temperature is this distribution, and you get a shift in the climate, you get a shift in the extremes. So under the old climate, here's the extremes of cold, and there's the extremes of warm. You get a shift, and you don't get the old extremes of cold, but you get a new type of extreme of hot, as well as the old extreme. That's the way it functions, and we're starting to see that with daily maximum temperatures in many parts of the world. Following on from that, you get all sorts of other effects, such as the rainfall declines. I spent just a little bit of time talking about southwestern Australia in its context in a Mediterranean environment, in the Mediterranean environments of the world. There's 5 Mediterranean regions. It might take a moment to get your bearings on this map. These are big maps of these little features here. The 5 Mediterranean areas of California, Chile, South Africa, Australia and the Mediterranean Basin. You'll notice that 3 of them, North America, South America and Mediterranean Basin, there's quite a lot of latitude. So as climate shifts, the biota has got some chance of moving polewards. Also, those 3 places have got a lot of mountains, so the biota can possibly shift upwards. South Africa is in the same boat in that it's got mountainous terrain as well. The odd one out, well, the 2 odd ones out are still probably Australia and South Africa, in that both have got no latitude to move, for the biota to move. Both are very old landscapes, and so they've got an unusual biota, which I'll explain a little later. Both, there are mountains here, but southwestern Australia really is the odd one out in that it's got no real topography to speak of. So the biota can't really move. So that places southwestern Australia as the most vulnerable of these Mediterranean systems. Furthermore, there's lots of models about climate change, and these are actually a bit old now, and they all show different stories for different parts of Australia, depending on the assumptions that you might take. But one thing they all have in common is they all point to a drier, warmer southwestern Australia, without exception. And the regimes since 1970 have been trending this way. Southwestern Australia is a pretty interesting place, and this deserves many lectures rather than a slide. But let me just say it quickly, that it's a big area, but it has over 7,000 vascular plant species, many of which are endemic. They're intricately patterned across the landscape, despite that subdued topography. Many of them show remarkable nutritional and other biological specialisations which relate to the landscape age idea. I won't dwell on that. There'll be some time later. Also, they show many interesting specialisations to life in a fire-prone environment. I've already mentioned that the impacts are high and the landscapes are flat. This sort of Richard Waldendorf really demonstrates that magnificently with his work. There's been some modelling to show what the future climate envelopes are for southwestern Australia. This is the Jarrah Forest bioregion. We're tracking more toward the high end, and this shows the brown shows climate environments that aren't what are there today. So we're moving out of today's climate as we move ahead. The Warren bioregion is even more extreme into how the climate is shifting. It might seem strange to people that there could be such big shifts. We're only talking 2 degrees or 4 degrees of warming, and we've only had 0.9 of a degree warming since around 1900. But have a look at Pemberton and Dwellingup, the maximum temperature there. It's only 1.5 degrees different, the mean annual temperature, between Dwellingup and Pemberton, and they're rather fundamentally different environments. If we go to Northam, we add another couple of degrees as the maximum temperature, of course. But we're not talking huge numbers. So a change of 1 or 2 degrees actually makes a difference. Now, under this situation, you'd expect the forest environment to be, in a sense, stuck in a bit of a time warp. You'd think it would be used to the old climate, especially the long-lived trees. So what are they going to do in the new climate? So we're doing research on the issue of the idea of museums of forest structure. Are these trees that are out there left over from a previous time? Can we grow the trees in the same way that we used to be able to? That's an area of ongoing research. I'm going to talk about fire soon. This is a quote from Joe Havel. Joe Havel was a notable forest ecologist who said climate and landforms together with fire set the stage on which the interplay of species takes place and determines the structure and composition of the vegetation. And there's been much research done on that idea. And some of my own work on landscape age and soil fertility and climate stability and fire regime are addressing those particular issues and how it impacts on the evolution of the biota. Haven't got time to talk about that now. Clearly, Australia, southwestern Australia, is a highly fire-prone environment. There's rapid fuel accumulation. Fuel is the biomass that is available to burn. In all environments, the vegetation is highly flammable. Lightning strikes are a very common feature of the southwest. And the soil dryness index shows you when an area can burn. So in the Jarrah forest it can burn over a long time, in the Karri forest less time. But nevertheless there is a period of time in the summer when the vegetation is very flammable and burns will be able to burn a large area of the landscape. And of course the species have been around for a while, and you'd expect the different communities to show different community level differences. So for example in the Karri forest, a great proportion of the plants have soil stored cedars and a small proportion of resprouters. But if you go to the Jarrah forest environment, a much greater proportion of resprouters compared with fewer soil stored cedars. These patterns can be discerned across the different environments. Of course, different species have different vulnerabilities, and so you do get relictual species species that have left over from previous climate regimes occurring in some environments, and you might expect them to be occurring in naturally less frequently burnt areas, given that most of the landscape is capable of burning. Some of these habitats are particularly vulnerable to fire, and I'll show an example of peat swamps here, which is a substrate which is highly flammable, which adds an extra complexity to fire management, and I'll come to that in due course. Under those circumstances, our group have been doing research on the idea of refugia. Where might the biota retreat to under climate change? Refugia are habitats that components of biodiversity retract to, expand from and persist in under changing environmental conditions. So they facilitate persistence of the biota. And you'd expect fire refugia to occur, and a fire refugium is an area that has a different fire regime, could be in frequency, intensity or patch size, than the surrounding matrix. So in the fire-prone southwest, fire refugia are likely to burn less often and with lower frequency. Fire refugia harbour, you would expect fire refugia to harbour species with different plant traits than the surrounding landscape. So some of our work's been directed towards this. For example, Paleta de Smet, a recent master's student, did a very interesting project on granite outcrops in the apron areas surrounding the outcrops and the areas on the outcrops, and found that the actual regime or the suite of plant traits differed for these species depending on whether they were growing on the outcrop or growing in the surrounding refugium. Again, it's not long enough, I can't speak. I haven't got time to explain in detail this, but there's a lot of interesting outcomes from that sort of work, which suggests that the idea of fire refugium is a reasonable one for southwestern Australia. Now, fire management, of course, has understood all these things for some time. I mean, since the 1960s, the Forest Department at the time has been very engaged with the idea of fire management. The 1961 Dwelling Up fire was quite a significant period in southwestern Australia's history. And following that period, or even prior to it, just prior to it, management has sought to manipulate fuel. And for some years, the low-intensity prescribed burning at 5 to 10 year intervals were routinely applied in blocks. They're illustrated here as blocks, but of course the reality is you never get a complete burn in that there's differences of intensity and pattern throughout the burn that might be undertaken as a management fire. The idea was to manage the fuel loads and the wildlife habitat to reduce the risks of damaging wildfires to assets, whatever assets they might be. Of course, a lot of the emphasis has been on human assets, but increasingly, in recent decades, there's been quite an emphasis on wildlife habitat, particularly, for example, animals like quokkas that need long unburnt but not extremely long unburnt habitat in order to thrive. Quokkas, of course, are native not just to Rottnest Island but to the southwest forests as well. With regard to prescribed fire and wildfire, the actual average interval between fires has been increasing for some decades. This year, interestingly, is the first year since 1961, which is Dwelling Up fire, when wildfire area was a greater area than the prescribed burning area. That's not yet shown on this graph, that's the next one there. But you can see there, things are changing in the way we're managing fire. There's risks and there's outcomes associated with this. Of course, there's the potential for reignition later in prescribed burning. so that the burning of the entire site is possible and fire escape is possible. That leads to that particular strategy of a longer distance between fires, longer time rather, between fires, leads to a coarse-grained mosaic, either from the prescribed burning itself or from wildfires. So areas requiring different regimes to the matrix may not be very well protected. Here's an example of a wildfire which has burnt all areas of the rock habitat, as well as what we might call a fairly complete fire in that area. Here, the burning of the peat at Lake Surprise, and here the Mount Cook wildfire, which shows a pretty, shall we say, clean, but certainly a pretty, well, that's a picture from Kirsten Pollock of the Mount Cook wildfire from 2003, which was quite an intense fire. The impacts on the biota for these different types of fires vary following fire. Depends on the particular circumstances. For example, in 16-year-old fuels, this is from the Mount Cook fire, we get this sort of impact, visual impact occurring, but the same fire in 5-year-old fuels didn't burn so intensely. Neil Burrows and his team in Calm and now Deepore introduced an idea called the Fire Mosaic Project near Walpole. Their aim was to create a mosaic, a fine-grained mosaic in the landscape scale to maintain fire refuges. The word fire, when I say fire refuges, I'm not saying fire refugia. Refuges are places, that's the English term. It's the places that animals and plants can retreat to in a ecological timescale. Refugia is the Latin term, and that's more to describe an evolutionary timescale. But of course, for long enough, they grade into one another. Using frequent fire in the landscape by using fuel flammability differences to manage fire. So looking at the season, the time since last fire, the moisture differentials, and using the different vegetation types, you can manage fire in the landscape. Now, it's expected that a fine-grained mosaic of interlocking cirral stages will promote biodiversity and reduce severity of the wildfires, and hence retain these fire refugia. That was the idea, and that work was implemented, and for several years fires were put into that landscape as often as reasonably possible. And so we get these different patterns following the fires, so that by 2011 we had this sort of picture of the landscape, which incidentally quite closely resembles the picture of the landforms and soils units for the region. In other words, the fires are linking quite well with the patterns in the landscape. So that sort of understanding is reasonably deeply embedded within fire management in Western Australia. But I need to return to climate change. Overlaying climate change on the fire management in southwestern Australia makes for more complexity. If we look at the Jarrah forest and the eco-hydrology of the Jarrah forest, we quickly get the picture that there's been less rainfall, about a 20% decline since 1970, and a considerably greater decline in the stream flow into the dams. A complex graph, but just follow the main lines and you'll get the picture. If we look at the rainfall, it's declined. If we look at the evaporation, that's increased. If we look at the differential between, in other words, the rainfall deficit, that's climbed, and the water into the dams has mirrored the rainfall deficit. So we're getting a picture of less moisture in the system. But a better picture of less moisture in the system is probably provided by the piezometer network, the network of boreholes that are monitored in the Jarrah forest that Alcoa have established decades ago. Here's an example of a borehole at Gordon, which hasn't been mined or logged. Well, it was logged some considerable time ago. All of the Jarrah forest virtually was logged. But it's ruled out that logging or mining has any particular impact on this. And what we see in this diagram is since about 1995, there's been a sudden decline, a straight line decline by 0.5 metre per year in the water table. Now, in the Jarrah forest, on at least the Darling Scarp area of the Jarrah forest, it's a very ancient landscape on the Yilgarn Craton. The bedrock is granite, and there's a considerable area or depth of regolith. The soil and other material can be up to 50 metres deep. And Jarrah, of course, can get to the water in that water table that's deep down above the granite bedrock. This diagram, if you follow it through, would lead to bedrock by 2026. This graph would be worrying. But unfortunately, all the graphs do the same thing. Whether it be high in the landscape, medium in the landscape, or low in the landscape, all of the piezometer scores for this part of the for this particular area are showing a similar trend. And Alcoa have now putting together a map of the water table across the landscape, because they've got sufficient boreholes where they can actually come to grips with this. And the picture's disturbing. This has been, the idea of hydrology in the Jarrah forest has been understood for decades, and I won't spend time on it now, but most of the water that falls to the ground it's a soil that you get good infiltration. Jarrah forest grabs the water on the way through and it transpires it. What's left over goes down and comes back out as stream flow if there's sufficient head in the system. We're noticing in 2010, when there was quite a drought year, that was the first year recorded when the inflow to the dams was less than the evaporation out of the dams in the Perth Hills. So it was a significant year, 2010. Following that, and these photos were taken early in 2011, we had deaths in the shallower soils around the base of the granite outcrops. So in that case, the water table had got to bedrock. Now, I mentioned the soil dryness index before. So the soil dryness index is a really neat way of looking at the flammability and burnability of the landscape. And the green line is for the soil dryness index for Dwellingup in 1970, or between 70 and 75. The purple, pink colour is a larger area under the curve, and that shows the soil dryness index today. In other words, with about a 20% decline in rainfall. You can see quite a bigger area under the curve and a high soil dryness persisting well into autumn. Under these circumstances, you have dry landscapes for longer, you have the refugia are flammable for longer, you have an increased risk of refugia burning more frequently and intensely. And this is the fire from 2003, which I won't spend any time on, but it's an illustration of sort of intensities we get, but of course you would expect this sort of thing in January. And just to remember refugia, while of course we could expect the refugia to maintain some elements of the biota for longer, under the sort of climate changes that are projected, the refugia all of the biota won't persist in these environments forever. And so we're noticing areas where, for example, Gillikin Rock, which is an outlying population of eucalyptus, of jarrah, and we're noticing those trees out at Gillikin Rock are starting to die off now. So we may lose that population quite soon. Now, I put the title on this, Conserving the Stage, because the stage is the substrate upon which the biota require to survive. And this is a species of frog that I did some studies of some years ago, one of my favourite frogs actually, Spicospina flammocereala. It's a neat frog that starts calling in sort of late November when the whole landscape is dry. And yet, of course, it has a 5-week tadpole stage. That's a silly frog to be living in such a place and starting to call at that time of the year. Well, it lives only in the peat swamps in Walpole. And interestingly enough, those peat swamps at Walpole don't start wetting up until about October, November. It takes a long time for the water to flow through the system and create the pools in which the tadpole stage of this frog persists. And we did a little work on this frog and found that it was a new genus, quite distant from all the other genera around the place. And its lineage goes back 30-odd million years, when there was a rainforest environment in the southwest and there was a lot more moisture around. So it's hanging on from the old days. But cutting a long story short, those peat swamps are rather important to this frog. So burning the substrate can make a difference. So one has to be careful both in the way we do our prescribed burning and in putting fires in so that landscapes don't burn during the summer in wildfires. This is the result of a loss of a metre in peat at Lake Surprise some years before. So fire in non-extreme and extreme weather conditions needs to be discussed briefly, because you'll be hearing about this out in the traps. Under non-extreme weather, fires are suppressible and they tend to burn heterogeneously, which is why it's nice to be putting fires in under mild conditions, so we have lots of islands around the landscape. Fires under those circumstances are greatly influenced by topographic position, by slope and by fuel load. And in that circumstance, crown fires usually absent. Under extreme or catastrophic conditions, weather is the major influence, much more so than the fuel. So there are circumstances when it doesn't matter about the fuel age, the fires are going to cause trouble. Okay, so that's an important differentiation there. But we have some lessons from fires this year which tell us what really is going on in these environments. Here's the Boddington fire. This burnt about 50,000 hectares just a few weeks ago. This was a lightning strike, one that wasn't able to be got to in time. And the temperature range during the several days that this fire burnt, it got pretty hot. It got to 41 there. But that happens in summer quite regularly. It's not unusual. The minimum humidity was not particularly low. The wind speed was very moderate. So this was not an extreme period during this fire. And yet the fire was quite difficult to control. I'll illustrate it further with the Northcliffe fire. This was the biggest fire since the Dwelling Up fire. This one's burnt 98,000 hectares in January this year. Again, this was a lightning strike at about the same time as the Boddington fire. Again, this area, the temperature was not extreme. The humidity was not particularly low. The wind speed was quite mild. In other words, the fire danger index was moderate rather than extreme or catastrophic. That fire was also very difficult to control. But notice something that's interesting on this diagram. The fire, this area here, was a wildfire in 2012. And the fire virtually stopped at that spot under those circumstances. Okay? So that made the control of that fire somewhat easier than it otherwise might have been. The Walpole district were also able to hold the fire in these areas as well. And it's largely about the fuel age under those circumstances. We're actually lucky in southwestern Australia. We don't tend to get the same sort of catastrophic conditions as what the Victorians get. Because when, in Victoria, when they get a northwester, it's come right across the continent. And it could be blowing pretty furious. So you could get 70 or 80, 90 kilometre an hour winds, as well as the 41, 42 degree heat. And that's when you have your catastrophic conditions, and that's when it hardly matters about fuel age. And we don't stand in the recent areas that are burnt in order to put the fires out. We just get the hell out of there. Just going to raise a couple of final points before I finish the presentation. This is the Mundaring fire in 2005. This is the overall outcome of the fire. Notice the proximity of people. This is the way it burnt in relation to the fuel ages of that area. You can see it was able to be stopped at various places based on the fuel age of the time. But that's only part of the story. There's a lot more to the story than just the fuel age and just the environmental conditions. People are part of the deal. And this is a slide from Phil Rundell from California, but it's the same the world over. The number of ignitions is strongly related to the number of people in the landscapes. And we're seeing more and more fires that are being deliberately lit at a time when they are quite difficult to control. So this is a sort of a summary slide of some ideas which we have to take into account in a climate changed environment. In the southwest forests now, we do have higher soil dryness indices. We've also got growth at the peri-urban interface. So the areas in the Perth Hills, around Margaret River and so on. A lot more people in the landscape than there were in the 70s and early 80s when I was lighting fires and putting fires out. There's been a lot of land use changes as well. We've had a reduced fire management capacity over recent decades, and we've got an increased bureaucratic complexity. Just the nature of the beast. When you've got a lot of people around, it's going to be much more, you've got to plan much more further ahead in the way you manage fire. So the results of that is we've got a reduced area that's prescribed burn, we've got larger, more intense fires, we've got greater risks to human communities, we've got additional stress on ecosystems and a longer period to recover under dry conditions. So, last couple of slides, the impact of changes in fire regimes on biodiversity under the climate change scenarios that we're seeing in the southwest, the direct impacts, the impact will be a function of the direct impacts of the climate change on the regimes, and you've seen quite a bit of that story already in this presentation. There's also issues about how the biota responds to the various attributes associated with climate, elevated CO2 and fire regimes. But probably the key thing is the choices that Australian society makes in dealing with both climate change and fire management. There's going to be a fundamental big deal is how we respond as a community. So in terms of the future of prescribed burning, we have got to bear in mind that prescribed burning is a tool in the fire management arsenal. It's an important tool, but it's within a climate change context, and we need to understand that deeply. We need to be considering prescribed burning when moisture differentials are high to achieve partial rather than complete coverage. Our windows of opportunity in prescribed burning are much reduced from what they were in the 70s and 80s. We have to remember the cost-benefit ratios of reducing the impacts of unplanned fires and the impacts of prescribed burns, because both could have impacts. Nowadays, much more than ever, we have to be informed and involved, and all of us have to be informed and involved in life decisions. We can't leave it now to the bureaucrats or the fire or the land managers. We've all got to be engaged in the process. Clearly, we need, from my perspective, I'm seeking a better knowledge of refugia and connected landscapes of the southwest, but there are all sorts of other areas that need to be researched as well. But we need to understand, achieve a better understanding of the limits of the capacity in fire-prone environments. So I'm leaving you there with in the air somewhat. I didn't promise solutions, but I did promise to alert you to the issues that we face in southwestern Australia under climate change and fire management. So I'll leave it at that, and we should be remembering that fire management for the protection of people and the environment under an increasingly changeable conditions that we now face. So if we don't acknowledge and deal with the issues of climate change in our fire management, then we are in serious trouble indeed. Thanks very much.